Alright, sorry I ran out of time on the last video, so let me just restart here on this one over here with the factor trees, just to make sure I get it all in one swoop here. So let's do factor trees for 60 and for 90. Alright, so 2, we start with 2. 2 goes into 60 30 times. 2 goes into 30 15 times. Now 2 doesn't go into 15. Now we move up to 3. Alright, you need to know your prime numbers, by the way. You need to know 2, 3, 5, 7, 11, 13, 17, and so on. You need to know your prime numbers. Typically for this class, the first 5 numbers will break up any number that you have. So now after 2, we go to 3. 3 goes into 15 5 times, and 5 is a prime number, and that's how you know when to stop. So 60 is the same as 2 times 2 times 3 times 5. Now let's do 90. 2 goes into 90 45 times. Now 2 won't go into 45, so now we go up to 3. 3 goes into 45 15 times. Now we stick with 3. 3 goes into 15 5 times. So that's the prime factorization of 2 times 3 times 3 times 5. So now to find the LCM, you ask yourself, what has the most 2's? Alright, 60 has the most 2's, right? It has 2. 90 only has 1. So we get both 2's from 60. Alright. Now we go up and say which one has the most 3's. Well, 60 only has 1 3, but 90 has 2 3's. So we get 2 3's off of 90 this time. Now which one has the most 5's? Well, this one has 1 5 and this one has 1 5. So they both have the same number of 5's, and that number of 5's is 1. And so the LCM is 2 times 2 times 3 times 3 times 5. And that works out to be 180. Alright. Now, just to show you, I think it is faster, in fact, to do it like we did this very first question over here. Let's write out the multiples of 60, because they're not that hard. 60, 120, 180. What are the multiples of 90? 90 and 180. And boom, just like that, you see that 180 is the LCM. So this method over here I do think is generally the fastest, especially for small numbers. I use the factor tree method when I get really big numbers, like if it was 54 and 84, you might be there while looking at 54 and 84. In fact, let's just go ahead and do those two numbers that I just made up, 54 and 84. Let's try that. Alright, so 54 and 84. Alright, so this could be pretty ugly, but let's just see how it works out. So we got 54 and 84. Alright, so 2 goes into 54 27 times. 2 does not go into 27, so now we go to 3. 3 goes into 27 9 times, and 3 goes into 9 3 times. So 54 is the same as 2 times 3 times 3 times 3. Alright, let's do it with 84. 2 goes into 84 42 times. 2 goes into 42 21 times. 2 does not go into 21, but 3 does, and it goes 7 times, and 7 is a prime number. Alright, so we've got our two factor tree. So the LCM says which one has the most 2's. Alright, there's 2 2's right here, so my LCM needs to have 2 2's. Now which one has the most 3's? This one has 1, this one has 3 3's. So I need to get 3 3's. Alright, now which one has the most 5's? There's no 5's anywhere, and the only other number is 7. This one has a 7 and this one does not, so we need a 7. So if we get out our calculator here, and we take 2, let's see, alright, 2 times 2 times 3 times 3 times 3 times 7. In this case, the LCM of these two awful numbers is 756. And that is about as difficult as one of these problems can get. This is obviously not one where you'd want to make a list of the multiples of 54, because I don't know those easy, and I don't know the multiples of 84, but if you did it, you'd probably find that it looks like 54 is going to be the about the 14th multiple of 54, and 84 is going to be about the 9th multiple of 84. 756 would be the 9th multiple of 84. So that's how you do those.